Hello guys, so in this video I'm going to talk to you about the various categorizations of programming languages. Right now, as a newbie, you see these type of terms thrown around like uh, dynamically typed, this language is statically typed, and there's OOP, object oriented, and all that stuff. So and these things can easily put you off, right? They can get you so confused as they, okay, what is going on here? Can someone tell me what's happening? Right. So I'm going to explain what all these useful programming languages categories mean. Okay, so that next time you see it, you'll be confident. Aha, I know what this means. Right. So there are usually five categories that you hear about, right? We have the compiled languages, the interpreted languages, we have the statically typed languages, the dynamically typed languages, and then we have the object-oriented languages. Now, you'd realize that there are some languages that like fit in one or two or three of these categories, right? So it's not always like black and white like that. I'm here and I'm not there. Okay, I can be here and be here at the same time, all right? So, and you understand why it's so really quickly, right? So let's just get into it, right? So the first is the compiled programming languages, right? So typically, right, before a user is able to use your software, right, it has to be turned into a format that the computer understands. The computer understands ones and zeros. Okay, so let's say over here you've written your code into y is equal to 6, s equal to 7, y plus 7. You enter that, and then the compiler takes all that information and then turns it into ones and zeros. Okay, in a language like C Sharp, for example, you can produce like an executable file. So you see all these setup files and stuff like you download, these exe files that I download, they are simply somebody wrote the code somewhere and converted it into that format for you to be able to use the software, right? And compiling it into these exe formats and stuff like that, it allows you to be able to easily distribute it and stuff like that. So compiled languages, this is the general approach that they take. So the program is compiled separately and then it is executed separately. All right, so languages like C, C++, Java, and this language, that is how they work, right? I'll throw more light on this with an analogy as we go on. Okay, so just keep this in your pocket in the meantime. All right. Now, interpreted programming languages, right? Now, people usually get interpreted and compiled a bit twisted. Okay, but I'm going to make it clear in this video, hopefully for you, right? So for an interpreter, right, just like the compiled languages, yes, you also need to convert it into machine readable code. Okay, but then the difference with that interpreted languages and compiled languages is that the interpretation occurs at the same time as the execution is occurring, right? So like in the compiled language, we have to compile it to the setup, and the setup has to be run, and that kind of vibe, right? But then for interpreted, once you write your code, you run it in whatever appropriate software it is, a browser or whatever it is, you just get your results immediately of what you are expecting. Okay, there's no intermediate stage anywhere, right? And I'll explain that as well. So interpreted languages like JavaScript, Ruby, Python, and all that stuff, for example, you write your JavaScript code, you open it in the browser, and boom, you get your results. Okay, you don't need to do any separate compilation and then executable and all that stuff. Okay, so all that is sort of merged into one process. Okay, now let's use this book analogy to sort of understand what this whole compilation interpretation is, right? And this is something I created, right, to just make it easier for you to understand. So let's take it like you wrote your code, right, which is let's say your C Sharp or your Java code, right? So we'll consider this Chinese book as your code, right? You and I at this point, I'm sure you also don't understand Chinese. Okay, so let's just say Chinese is your code, and your users do not understand Chinese, right? So this Chinese has to be sort of converted to English some way for them to be able to use whatever you've written or apply whatever you've written, okay, in your final product, right? Now for compiled code, right? Let's take that this over here is a book, right? Your software is like a book. The code you've written is a book. So what the publisher will do is that the publisher will translate and publish different multiple English translations. Okay, so like I said, the in compiled languages, the code is converted in something like an executable. So take this as the executable, right? So for this you can compile, build so many executables, which is the English translations, right? Now for this, anytime the end user takes the book, everything is already translated for them already. Okay, all errors and stuff like that have been fixed. Everything is translated for them already. So they take the book and immediately they can just go through it without any hassle. All right. But here's the thing. Imagine you publish the book in English. You translated your book, your code from Chinese to English, right? And you sold the book out there. Now people have the English versions of the book and they are reading it. They are happy, right? But you discovered later on that there was a typo in the book. Now what happens? You'd have to go back and then republish all the English, republish new English versions again to fix that error. You get what I'm saying? Yeah, you have to republish everything again. You can't go into everybody's book and then use like a pen or something to adjust the information in there. So you just have to republish new batches of the book. Okay, that's how compile languages are. So anytime you compile your software into the executable and there's an issue, you have to recompile it all over again, or you get it and get a new version of the executable, whatever it is, before you can run that as well. So take that analogy, think about that analogy, because that's like the core building block of compile languages, right? Now another thing too is that for a compile language, right, so if you write your program and you are doing the English translation, whatever device or whatever computer device you are running your code on is what will be that's what will be used to convert it. All right, so if you are building on an i7 computer or a 32-bit computer, 64-bit computer, that is what will be used to build the final executable. All right, so that is one key difference in the compile languages. Now let's compare this to the interpreted languages, right? So for the interpreted languages, now the fundamental difference is that there is another software between your written code and then your final English translation, right? So what happens is that in this case, example, the browser, right? The browser can be like the interpreter. Now, for the interpreted languages, everything is done on the fly. All right. So immediately you pop your code open in a browser, the browser interprets it, compiles it, executes it right in the browser. So immediately you get to see your English translation, right? If any user visits your website, they immediately get to see the English translation of your code, right? Which is the final English translation here, is the final output, right? So the browser is sort of reading and outputting all the time, reading and outputting and converting and executing all the time in real time. All right, so in this scenario, if any change, if like there should be any typo in your site or something, all you have to do is adjust it in your code, and immediately you see that right again in the browser, because the browser is the one handling the execution and the and the interpretation of your code. Okay, so that is what is in charge of showing it in real time. So it is not your computer that is immediately compiling the stuff that you've written. Okay, and that's one key difference between compiled and interpreted language. Okay, so for this, whether your user is in China or is in Japan or is in Nigeria or is in America, whatever it is, immediately they visit your site, they see the new version of your translated book or your translated code, right? This is something that once you get, you begin to appreciate it more. So languages like JavaScript and all that, immediately you run it in your browser, they pop up the results. Okay, you make the changes, they immediately pop up. But the compiled languages, like I said, you have to sort of rebuild everything again as an executable and then run the executable and all that stuff. So one key difference. But the thing is, one thing about the compiled languages is that they happen to be relatively faster, right? The outputs happen to run a bit faster because you have already compiled the thing. So the next time your user takes it, they're already reading something that has already been translated. Okay, it is not now being translated in real time. But with the interpreted languages, they are sort of being translated in real time. So they definitely have some overhead. Okay, so these are some differences over there. Okay, so now on to the next thing, which is statically typed programming languages, right? So static typing means that when you initialize a variable in your code, right, you need to determine the type of variable, right? At the time, the time that the program is compiled, the program needs to know what data type, whether it's an integer, whether it's a string, whether it's a floating or a boolean or whatever it is. It has to be defined. All right, and once it's defined, you can't just change it. So in this example, we said int y is equal to 6. You can't come on later and say y is equal to new string. That will pop an error. Okay, once the language is being run. Okay, so the data type is not allowed to change, right? Obviously, I mean, technically, if you are coding, there are stuff like typecasting and all that stuff that allow you to convert certain types to other types and all. But then, basically, this cannot be done. It will pop up an error. So you see syntaxes like that in languages like C, C++, and Java, okay, which are statically typed. Now, dynamically typed programming languages, their types are established at runtime. Okay, so once you declare the variables, you don't really explicitly say something like int. It's sort of like open out there. So intrinsically, internally, right, these types are sort of determined as they are being interpreted. Okay, so variables can change and all in the process of program execution. Okay, so you can say y is equal to 6, later on come and say something like y is equal to a string, and you are all good. Okay, it's not as strict. You get, and sometimes this can lead to errors and a whole lot of bugs and stuff like that. I mean, it's one of the downsides of dynamically typed programming languages. Okay, so in languages like JavaScript, they are new. That is why TypeScript and all these guys have become really popular. Okay, because they bring in some discipline in variable declaration and defining data types. All right. And object-oriented programming languages, you usually hear OOP, and all that. So these allow you to represent certain constructs in your code as objects. Okay, so like these objects usually represent real things, and they are like some sort of blueprint for creating more of their type. Now, this is a bit abstract, okay, but you see something like classes. You see a language and you see something like class something, and there's a whole lot of definitions going on there. But I'll explain it in an analogy. Okay, so let's take it like this. Let's say you are writing a code, right, that like a program that allows people to sort of display a certain type of building they want, right? So what you can do is that in your code you can declare something like a class building. Right now, every class has like some properties and functions and methods, right? So like this building, without any customization, has a paint color. The building is supposed to have a paint color. There's supposed to be like some type of wood that is used for developing maybe the floors and stuff like that, right? And then the building too comes with like a function which sort of combines the paint color and the wood type to form the building. All right, so this is like a blueprint. Take your class like a blueprint, like an architectural design, and from that architectural design, multiple varieties of the same building can be developed. All right, so for example, using this same blueprint here, we're able to build a yellow building. Okay, we didn't have to write a whole new set of code for just yellow building. All we used was leverage on the existing blueprint, the existing class, and then simply customize the variable. So we said yellow building is a new building, and then this time around the paint color is yellow. Right now for the red building, we said the paint color is red. For the blue building, we said the paint color is blue. So for all of them, we are using the same construct over here. All right, we are not writing whole new building construction code over here, right? So this is like one of the core concepts of object-oriented programming. So it can be not just building, it can be like a shoe or a car. You can have a class, maybe car, and the car has like steering wheel property and maybe color property, and then people can look at the architectural design of the car and then sort of build different varieties of the car. So that's usually what OOP is about. So designing your programming, your software, right? You sometimes have to understand what are some of the objects in the software. So like example, for an e-commerce platform, an object can be like a product, right? So you can have so many products on the platform, but then every product comes with a price, it comes with a picture, it comes with an image, it comes with maybe a discount and some description. Okay, so the products can be a class, right? Maybe you have a customer. Customers have different names and addresses and all that, right? But then you can have a blueprint for a customer so that every customer have these methods. So you can have like a class customer, right? And this is basically how the concept of it. So once you get it, then you get what OOP is all about, right? So thank you for watching this video. I hope I could explain some of these programming language categories to you, and I hope you understand. If it happens that like you're a bit confused about things though, just drop a comment on this video, and then we'll be glad to give you like some support, right? And if you're not subscribed, please subscribe to the channel, like the video, share with your friends, people that you think can help them, all right? And show us your support. Okay, so thank you very much once again, and bye bye for now.